Welcome back. We're going to continue on now. This is key questions 3.3 and this is question 3 and 4. Question 3 is going to use the formula that the velocity of A relative to B is equal to the velocity of A minus velocity of B. You've seen this in its other form, in its additional form in the textbook. This is just a quicker way of remembering things. A rel B, that's the symbol for relative. A relative to B is equal to the velocity of A minus the velocity of B. Okay, so in this case here we've got a boat and it's pushing off from a pontoon. So let's it's a north-south situation. So here's our river and a boat, okay, and it's going to travel eastward. So it's going to go to that direction, that's towards the east over here, and the pontoon is floating and it travels south at this stage over here. So the boat pushes off at 2.5 meters per second. And the pontoon moves south. Oh, sorry, did I say 2.5? It's not. It is, just let me get that one. The boat is 5. Sorry, I've read the wrong question there. So it's 5 meters per second. And the boat, the pontoon floats south at 2 meters per second. Okay. So relative to an observer on the outside, so there's our observer, that observer views everything in reference to the ground. The boat will move sideways at 5 meters per second and the pontoon moves down 2 meters per second. Okay, now what would a person on the boat the boat view the pontoon's movement. So it's the pontoon, calculate the velocity of the boat relative to the pontoon. So we want the velocity of the boat relative to the pontoon. So that would be the velocity of the boat minus the velocity of the pontoon. Okay, so it would be the 5 meter per second vector. So it's this vector minus that vector. So that's the 5 meter per second minus the 2 meters per second. To subtract these two vectors, I would have to add the negative of the second vector. So it's the minus 5 meters per second. So it's the 5 meters per second adding with a 2 meter per second in the opposite direction. So that would be that plus that. Okay. And that's the 5 meters per second across there. It's the boat, and this is the negative of the pontoon, and there would be a resultant vector. So our resultant vector, its magnitude, the magnitude of the resultant vector would equal the square root of 5 squared plus 2 squared, which is 25 plus 4, so it's root 29. Which is 5.4 meters per second. So, and it would be at this angle there towards the horizon. So theta, working out with theta is, so tan theta would equal 2/5. That would give us theta equaling shift tan, inverse tan of 2/5. That's 21 degrees. So that's 21 degrees there. And if you want to use a bearing, it would be 90 minus that. That's 68 degrees. So it would be this, so resultant vector here would equal 5.4 meters per second at 0.68 degrees true. Okay, so that's question 3. It's so much easier to use this little formula here because it's the way you say it. It's this relative to this is equal to this minus this. It's just so much easier than trying to work out with the addition of vectors. Let's have a look at question 4 now.